So in this video I'm going to discuss Codeforces around 936 rated for division 2. So I will be solving first three problems of this problem set. So let's start with problem A, that is median of an array. So in this question I will be given an array A of total n size. So median of an array is defined as the middle element of my array in its sorted manner. For example, if this is the array and I sorted, then the middle element would be the median of this array. So we are also allowed the operation to perform some number of operation. And what is the operation? I can simply increase any number by 1 in the array. And I have to finally increase the median value of my array. For example, if this is my array 2 to 8 and the current median is 2 only. So if I increase this 2 to 3, then my median is also increased to 3 also. So what is the minimum number of operation which I can perform in this array so that my median is increased in the final array? So how to solve this problem? So there's a hint, like how is the occurrence of median itself related to the answer. So let me tell you the answer now. So for example, if this is my array, like I'm writing 2, 3, 4, 4, 4, and let's suppose here it is 5, 6, 7, 8. So tell me what is the current median. I think so current median is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median would be 1, 2, 3, 4, 5. That is 4 only. Yes. So if I increase the occurrence of all the fours, then my median should definitely be increased. Let me this part. So if I make each of the element equal to 5, 5, 5, then in a sorted manner, my median is always increased. But this is not the minimum. I have to find the minimum number of increases. So tell me whether increasing this 4 is beneficial to me at all or not. It is not beneficial. So I will only increase the that part which are greater than n by 2. Okay. So for example, I will increase all the occurrences of 4 which are greater than my middle index. So that's my answer. For example, let me take another example like 1, 2, 3, 3, 3. For example, there are multiple threes and many more threes like here, and 1 5 here. So what is the current median? I think so. Current median would be this only, like 1 2 3 4 5 elements here and 5 elements this side. So what is the answer in this case? So answer in this case would be 1 2 3 4 5 6 7 8 8. No, but this it's not the answer. So I will first of all find the middle index and find the occurrence of all the threes beyond that. So that is 1 2 3 4 5. So 8 is not my answer. My 5 is only answer because I will only increase these 5 threes to 4. Then my median will always be increased to 4, and increasing these three threes would not be affect my answer at all. So that's how you can solve the problem number A. So let's now discuss the next problem, that is problem B, which is maximum sum. So it is pretty much interesting problem, I would say. So because some of the models part is making this problem pretty much interesting. So in this question I will be given an array. Okay, and what I can do, I can simply find the subarray of any sum of any subarray in this array. Okay, and finally I can add that sum of any subarray in the current array only, and repeat this operation k number of times. Yes, repeat the sum k number of times, and I have to find what is the maximum sum possible of my array after performing k number of operation, and I have to modulus it with 10 to the power 9 plus 7. So how to solve this problem? So there's a hint before jumping to the solution, that can you think of Kedan's algorithm for solving this problem? So if you are able to solve this problem, then good. Then next I will tell you the proper way how to solve this problem. So let me tell you. I have to tell you that you can use Kedan algorithm. Yes, right. So let's suppose this is my array. Let me take any array from this. So I am picking this array for an example. So what is the maximum sum possible of any subarray in this question, in this subarray itself? So I think so that's only this part, because the sum of this part is again 10 only. I think so this is the maximum subarray possible, or maximum sum of subarray possible in this subarray, in this array. So how you can solve this problem optimally? So what I will do, I will first of all find the sum of maximum subarray and repeat that part only. For example, I can only perform one operation in this case. So what I will do, I will simply add this. I will simply find the maximum subarray and add it here only, because I have to add the sum of the subarray any, because I can add sum of that maximum subarray in anywhere in my array. So greedily what I will do, I will for example, let's in this case this is not 1. Let's suppose this is 3 in this case. Okay, so for now what I can do, I can simply add this 10 anywhere in my array, but where I should add, so that my, so that it's beneficial to me in future also. So if 10 is my maximum subarray sum, I will add it to the near of this subarray only, which is yielding me the maximum sum previously. So that is 10 only. So I will write it here 10, because it is giving the maximum sum. Let me change the color. So I will 10. mm, I will write it 10 here. Okay, great. Now again tell me what is the maximum sum possible? That is now again this part only. I will simply again increase my sum to this part. And what is the sum possible? Now my sum possible is 10. 10 is this sum, and 10 is again this. So 10 plus 10, that is 20. So I have performed operation 2 times. Now I am coming with 20. Now where should I add 20 in this existing array? I will always add 20 near my existing maximum subarray, that is this only. So I will write it 20 here. Now which subarray is giving me the maximum sum? Now I hope so you are getting the pattern. So so this is the only subarray which is giving the maximum sum, that is now 30 that is now 40. So 40. So what is the maximum possible answer in this case? That is 40 minus 12 plus 9. Whatever the answer, that is the maximum sum possible in this question. So that's how you can solve this problem. But there's also catch. Let me tell you what is the catch. For example, I'm also having example like 2, 2 and minus 4 and minus 7. So in this question what you will do? You will simply define the maximum subarray possible, that is 4, and repeat the operation 4 times. 2 times, which is you will add minus 4 again here, and that is minus 4 minus 4. Then you will add minus 8 here and find the answer of this. No, but this is not a possible. By because I will always I have to also take a modulus operation. Now the sum of whole this array is like minus 4 minus 7, that is again equal to minus 11. But if you take minus 11 modulus 10 to the power 9 plus 7, that is again very much bigger, which is again 10 to the power 9 plus 7 minus 11, which is again very much bigger than what you are initially getting. So you have to take in account that all of these operations are also valid. But this approach will always work in such case also. But what is the final approach? Using Kedan algorithm, find the maximum subarray sum, and repeat that sum again and again into that existing subarray only. And each and every step your sum will increase by 2x. For example, let if this is my current subarray. So let's suppose in this case, what are use of current subarray of maximum, which is maximum sum possible, which is 8 to 4, and it is giving you 10. Now in the next operation, you will add 10 in itself only. Then my subarray would become 10, 4, 8, and minus 2. It is giving you 20. Now in the next operation, you will add 20 here. That is again 20. Okay. Now for this sum, this sum is 40. Then you will add 40 in my subarray, not repeat with 10. Which means if for each and every turn, what you are adding, you're simply adding for example, what if first the sum, then sum into 2, that is 20, then again into 2, that is 40. So in the next iteration what you will add, you will simply add 80. Then in the next what you will add simply 160, and similarly repeating until your k is over, and you have to repeat it until k times. So that's how you can solve this problem. So if I show you the code is also pretty much very easy. First of all, what I'm doing, I'm simply finding the maximum sum possible using Kedan's algorithm. So it is a basic Kedan algorithm code. You can find it anywhere using on Geeks for Geeks also. So this is maximum sum possible. And what I'm doing next, I'm simply adding the sum in my sum itself and finding it with modulus, and also adding my sum into sum, because that's what I will add in my final answer, because 10 plus 20 plus 40. But that's what I'm doing here. And also the don't forget to add on the sum of existing subarray, existing existing array, because that is also going to add in my array. because at the end I have to find the sum of the maximum. I have to find the maximum sum of the subarray, not the maximum sum of the array, not the subarray. That's why what I'm doing, I'm simply calculating the sum of the array itself before finding the answer, and again repeat finding the maximum sum and repeating the answer until k times, and don't forget to modulus it. So that's how you can find the answer of problem B also. So let's now discuss the last problem which is able to solve this problem set, that is B, tree cutting. So in this question, let me teach you here only what question is asking you to do. So for example, if you are having a tree like here, you are giving a tree. Okay, so let me make a tree. First of all, it is a random tree and nothing making sense. Although, okay, so in this question, what I have to do, I have to simply delete some of the edges. Okay, I have to delete some of the edges in this tree. Let me delete this tree. Let me erase this. Uh, okay, so let me erase this one. Okay, now let me. For example, I have to erase some. I am giving a target like you have to total number of remove three number of edges in this tree. Okay, so I will simply remove this edge. Okay, now I can also remove this edge. Okay, great. Now I can also remove this edge. Okay, great. So now tell me, what is the maximum component size by removing at most three edges? That is again 3 also. So what is the, so tell me what is the size of, so what is the minimum size of any component now? So the, for example, I have total now having 4 components. The size of this component is 4. The size of this component is 3. That is again 3. That is again 3. So total 3 sizes maximum possible. Which means after applying 3 cuts in my disk tree, the maximum component size is 3, which I'm getting. So that's what I have to give them to the answer. I will be given a n, that is the size of the tree, and a k, that is the number of cuts you are allowed to perform on this tree. Okay, after that, but I have to give them the maximum possible size of any component in this tree after performing k cuts. Okay, so I hope so the problem statement is pretty much clear to you. But how you can solve this problem? For example, this is example, and this is example number one only. So I can perform one cut in this answer, in this question, in this tree. So let me make it cut here, that is 1 and 3. So what is the maximum possible size of any component after making one cut? That is 2 only. So answer for this question is 2. So that's what you have to find in this question. So how to solve this problem? So let me tell you the approach directly, because okay, so how to solve the problem? Let me rejoin the my tree. Okay, so this is my original tree, and k given to me is like 3, which means I can at most perform 3 number of cuts in this tree. So in this question, let you um, change answer greedily. What is a greedy answer? For example, you can simply use a binary search approach in this question. But how a binary search approach operation which work? So let me suppose, what is the maximum size possible? That is the number of component. Okay, that what are the number of component in this tree? That is 1 2 3 4 5 6 7 8 9 10 11 12 13, whatever, let me take it 13 only. So 13, so total number of 13 components are there in this tree. So first of all, what I will do, I will simply try to find the for the middle one. Let me take that this is my middle one, which is something around 7 only. I will take it 7 in this case. So let it 7. So first of all, what I will do, I simply try to make my component of size 7, and try to find what are the number of cut possible, what are the number of cut required to make each and every component of at least 7. Okay, so how you can do this? You can simply do this greedily. How greedily? You ideally start from leaf nodes, okay, and start submerging leaf node into its parent node. Okay, great. So let me take it here. For example, I will submerge these three leaf node in this parent. So how many? What is the value? For example, let me take another case. Like first of all, each of my node is equal to one only, which denotes the number of vertices it currently denotes. Hypothetically, it's not making sense now. But if I merge this one into this one, okay, then my value for this node would be 2. and I have to also erase this edge. So now my this edge is equal to 2, which means this is currently equal to two vertices in my tree. So I will also submerge these two leaves in this leaf only, in this node only. So that is now what is our final value of this? The final value of this would be 4. Okay, so let me erase. So final value for this is 4. Okay, great. So now what I will do, I simply try to do the repeat the operation from the leaf node. I will merge this. So now this will become 2 and this is no longer an edge. Okay, now we'll merge this. That is again 3. Okay, that is again 3 and this is no longer an edge. So I will remove this 3, and but is this what this 3 represents? That is represent the number of nodes which is currently holding 1 itself and 2 beneath it. So I will now also merge this 4 with 3. Now what is the final value? The final value is 7. Okay, the final value is 7. Great. So now tell me, can I merge this further up? No, because I cannot merge this further up because I have taken that each of my component size can be equal to 7 only. So at most I will try to make it to 7 only. If I'm getting a value greater than 7, then I will make a cut there. Okay, hypothetically I'm making cut there. So where I'm making cut? So I will making cut here. Okay, because the size of this my component would be 7. That's what I'm getting here. Okay, this is not 3, now this is 7. So what is this 7 represents? That my current height of that my number of nodes in this subroot would be 7, and that's what I'm wanting here. I will make it cut here. Similarly, I will merge the tree from this side also. Then what is the value? 1 2 3 4 5 6. So that is again 6 only. Okay, so I will erase this much part also. So now tell me, how many cuts have you made? So total number of one cut I will only making, but how many cut are required? Total number of 3 cut are required to get the answer. But no, I'm only getting one cut. So my number of desired cut are smaller than my number of required cut. So that's not what I'm getting here. So I will make my binary search shrink, which means 7 is not my answer. So I will try to find in a lower search space, that is here. So I will try to find the 3. Let me take a middle value as 3, hypothetically for getting the answer only. So make it equal to 3. So let me revive the my last tree, which was it. Okay, so this is my previous tree. So you can now you know that my 7 cannot be answered. So I will try to do it for the same as for 3. Okay, for 3 also. Okay, now what grade? So what I will do, I will simply try to make a tree. Okay, great. So I will merge it. So I will merge all this. I will merge all these 4 nodes. Okay, I will make it equal to 4 and erase it, because you know in the answer my size should be at least for 3, not at most 3, which means I can always get a greater tree with a greater subroot which value more than 3. Okay, because you know this is the question which if I again tell you the question is asking the you find the maximum number of x such that it is possible to remove exactly k edges in this tree such that the size of the remaining component is at least k, not at most k, at least k. So what I am getting at least 3, which means I can get a component of size 4. But I will greedily try to make a cut here because this is beneficial for me. So we make a cut here. Okay, great. So now what edges I will now retain. So total number of 3 edges, now one more retain I will. So for example I will 1 2 3. So let me make a let me now combine these 3 edges. Okay, great. Let me now combine these 3 edges, that is 3. Now size of this is also 3. So now this is also coming a 3. Now I will again make a cut here. Okay, great. Now I'm again making a cut here. Okay, great. Now but next I will also now you know I will always starting from my leaf nodes. Okay, so the value of this 3, the value of this node would be 3, which means at the end my this node would become 3 only. I will make it 3. So my this node would become 3. Okay, great. Okay, and I will erase the extra part which I have drawn. So okay, drawn, erase. Now at the next what I will do, I will simply make a cut here because I am getting a size of 3. Now at then what tree I will making? It is always clear that this is the tree which I am next going to cut. And you know how many cut are you making? A total number of 3 cuts. Which are you making? Which are you making? So that is the required number of cuts. I am also getting the answer. So that's the one possible answer. So if I'm getting the answer, now I will try to find a bigger search space. Now let's suppose I'm getting a 5 here. So for 5, similarly repeat the process and check if your number of cuts, if your number of cuts which you're getting from this DFS algorithm are greater than or equal to the desired number of cuts. If this is a condition possible, if this condition is meeting you, then the answer is yes. Else answer is not. Else you have to shrink your search space to lower values. So that's how you can solve the problem. Where see, if I show the code is also easy. First of all, what I'm doing, I'm simply taking the input of the my edges and making a binary search here. So I am so that's the solution which I found in the editorial part, because it is a pretty much clean implementation of the solution only. So you can always refer this. What I'm doing here, I'm simply first of all making my value set, because this is a current count is equal to 0, which is the cut count, the cut which I'm making here. Okay, minimum size is equal to mid. For each and every binary search solution, I will make a minimum cut, minimum size equal to mid. That is, for example, in this case my minimum size is 3, so I will make my minimum size equal to 3 only. That is my minimum size equal to 3. Now what, I will run a DFS algorithm. Now for each and every leaf, what I'm doing, I'm simply try to merge into the parent. If my current size of my child is smaller than my minimum size, then I can always merge it in my parent. What I'm doing here. But if this is not the case, which means my current size of my, for example, in this case, you can see if my current size of my parent is greater than my minimum size, then I have to make a cut. So what I'm doing, I'm making a cut, I'm increasing my number of cuts. So how I can find the answer? If your current cut is equal to k and your last size, which is the list number, you can know. But the size of my root node is small, greater than or equal to minimum size, which means if you are getting a 3, then my size of this one should be greater than or equal to 3, because that's how you can find the answer. Okay, so if your cut are greater than number of k, then also my answer is valid, and that's how you can find the answer. If you're confusing with this situation, by the number of cards are greater than k or also matter, the answer is lying between in this line only. The number of components should be at least k, because if my number of cuts are greater than equal to cut count, then my answer should not affect, but I will always get a correct answer. So in that case, return 1, else return 0. So that's how you can solve the problem C also. So if you have doubt in any of this problem, you can comment me down. And till then, stay tuned for next one. And you will find all the code in the description or in the comment part. So please don't forget to subscribe my channel. Till then, stay tuned for the next one. Thank you.